In problem 10.4, it asks you what products would you expect to obtain from monochlorination of 2-methyl-butane. So 2-methyl-butane, the longest chain is butane, and so you can draw something like this. That's a butane, and 2-methyl, number 2 has a methyl group. All right, this is line bond structure. For clarity, we should add all carbon hydrogen as shown in this structure. All right. Now, chlorination reaction is the reaction to use chlorine to replace all the hydrogens by chlorine. So how many types of hydrogens in this molecule? Okay, this is a type 1A, and this is a type B. Okay, in fact, B is a secondary, and A is a primary. And here is another one, that's the tertiary. And this one is again primary. All right. In fact, you have 3 of them the same. Now these hydrogens are also as D, so same. So all 6 hydrogens, they are equivalent. So you have 4 types of hydrogens, A, B, C, D. Okay. So when you replace one of these hydrogen, note that it says mono. So you only replace one hydrogen. If you replace one hydrogen by chlorine, all right, this is the product. Okay, if you replace hydrogen B, you get second product. If you replace type C hydrogen, you get this tertiary chloride. And if you replace one of the 6 D hydrogens, and this is the product. So we predict 4 different products. Okay. Next question is, what would the approximate percentage of each product? All right. So in order to estimate what the percentage of each product, we need to look at the reactants. How many hydrogens do each type have? Okay. For A, you have 3. For B, you have 2. For C, you have 1. For D, you have 6. Okay, so if all these hydrogens has the same reactivity, then this is what you get, the ratio. Okay, because the more hydrogen you have, the more possible the hydrogen will be replaced by the chlorine. So the product ratio should equal to the number of hydrogens in the reactants. However, we know this hydrogen has different reactivity. Tertiary is the most reactive. So this is the most reactive, and this is the secondary, and then primary. But what is quantitatively the reactivity? Now in the textbook, we have chart right before this question, and it says if primary reactivity is number 1, then secondary is more reactive, so it should be 2 and 3.5, and the tertiary is 5. Okay, that's the relative reactivity. All right, and the D is also primary, so it's also 1. Okay, so this is the number of hydrogens. This is relative reactivity for each hydrogen. And so what is the product that could be formed? You should combine these two together. So you multiply 3 plus times 1 give you 3. 2 times 3.5 give you 7. So, and 5 times 1 give you 5. And then this is 6. So this is a relative ratio you would expect by considering both reactivity and the number of hydrogens in the reactants. Now to calculate the percentage, we add all these together. Give you all together is 21, and then you use each of them divide by 21. So 3 divided by 21, and that give you 14%. And then 7 divided by 21, 33%. All right, and this is 24, and this 29, and therefore we estimate the product ratio for all these 4 products is like this: 14%, 33%, 24%, and 29%. Problem 10.11. How would you carry out the following transformation using an organoil-copper coupling reaction? Now, organoil-copper is also called the Gilman reagent. And the coupling reaction is between an alkyl halide and a Gilman reagent. So if alkyl halide is R1X and the Gilman reagent is R2, okay, 2 copper lithium. All right, so we use R1, R2 just to show these two may have different alkyl group. All right, and in Gilman reagent, you should have dialkyl copper lithium. All right, you have 2 of them. All right, when these two add together, okay, this alkyl group from alkyl halide combine one of these alkyl group in the Gilman reagent to form a larger molecule. And that's why it's called the coupling reaction. So now let's look at the question 1, question A. If you compare reactants and the product, you can see a methyl group is added to the reactants. So the coupling reaction must be between a alkyl halide, which is possibly this molecule. So this has a chlorine, that's alkyl halide, with a Gilman reagent with probably dimethyl copper lithium. So when these two add together, so this alkyl group with one of the metal combined, that will give you this product. And then the question is, how do you make this one? So how do you use reactants to make alkyl halide? So this is achieved by chlorination of allylic position. And this type of reaction we skipped in the lecture, so you don't need to work on A. All right, but if you are interested, it's not hard, so you can look at the textbook. Now let's look at B, question B. All right, again we compare reactants and the product. Reactants has 4 carbons with a bromine, so that's the alkyl halide. All right, the product actually have 8 carbon, so 4 of them must come from this alkyl halides. All right, the other 4 must come from a Gilman reagent. All right, so we already have one reactant, that's alkyl halide. We need another one, Gilman reagent. So the question now is, how do you make Gilman reagent? All right, use these reactants. All right, so first, okay, forming of Gilman reagent. Okay, now this is the good time you go over the material, how to make a Gilman reagent. The first step is alkyl halide. You need to form a lithium reagent. To do that, you just add lithium. So alkyl halide, that's the reactants. Add the lithium in a solvent like pentane. That will give you alkyl lithium. Note that when you make alkyl lithium, this carbon becomes a negative charge. Okay, from positive carbon becomes negative carbon. All right, and then the second step. So this is the first step. You add lithium, forms a lithium reagent. The second step, you add copper iodide. When you add copper iodide, okay, then 2 of these alkyl groups combine the copper, and also a lithium forms the Gilman reagent. So this is a dibutyl copper lithium Gilman reagent. So now we are ready for the coupling reaction. All you need to do is combine the alkyl halide, which is provided in the question, and the Gilman reagent, we just synthesize this one. When they add together, these 4 carbon and one of these 4 carbon combined give you 8 octane, and that's the product. Now these lithium bromide, those are byproduct. When you write the reactions, you don't have to write them. So focus on the desired product. In question C, the reactant has 5 carbon and the product has 10. So obviously, to make the product, you need a coupling reaction. So 5 carbon comes from alkyl halide, the other 5 comes from Gilman reagent. So this one must probably is CH3, CH2, 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 CH2. So you have 5 carbon with a chlorine or bromine. That's alkyl halide. And these 5 carbon comes from a Gilman reagent. Gilman reagent CH3, CH2, CH2. So it's pentyl. So see, 3, 4, 5. That's a pentyl, but you have di. Okay, 1, 2, 3, 4, 5. Yeah, dipentyl copper lithium. All right. So if you combine these two together, all right, then this alkyl group and one of these from the Gilman reagent combined, that will give you a 10 carbon alkane. All right, that's the coupling reaction. So now the question is, how do you make this alkyl halide? How do you make this Gilman reagent? Because all we have is the double bond. We need to use this double bond to make this alkyl halide and the Gilman reagent. Okay, the Gilman reagent can be made by this alkyl halide. So the first step is to make pentyl chloride, bromide. All right. Now in organic 1, you learned that double bond can undergo electrophilic addition. For example, if you add hydrogen bromide, all right, then you can make alkyl halide. However, this reaction will follows called Markov-Nikov rule. Markov-Nikov rule means the hydrogen will go to the carbon that has the most hydrogen. So the double bond and the carbon has 2 hydrogen. So hydrogen goes to here, and the bromine will goes to here, and the product will be CH3, CH2, CH2, CH, CH3, bromine. Okay, so hydrogen adds to the end, so you have 3 hydrogens, and the second carbon has a bromine. That's not what we want. Okay, we want the bromine should at the end carbon, okay, not the second carbon. Okay, so is there a way we can add a functional group at the end? Well, again, in organic 1, you learned a method to make anti-Markov-Nikov product, and that is the combination of borane and hydrogen peroxide in basic condition. So step 1, you add borane. Step 2, hydrogen peroxide and hydroxide. Okay, if you combine these two together, a double bond will make an alcohol according to anti-Markov-Nikov rule. Hydroxy goes to the end hydrogen, and the hydrogen goes to the carbon has least hydrogen. All right, that's the anti-Markov-Nikov rule. All right, so after you make this alcohol, how do you make the bromide or chloride at the end? Well, this is a primary alcohol. In this chapter, you learned that if it's primary alcohol, you can add either thionyl chloride to make a chloride or phosphor tribromide to make alkyl halide bromide. Okay, if it's tertiary, you add HCl. All right, so if you forget about this, go over this material. How do you make alkyl halide from alcohol? Now we have this bromide, alkyl halide. Next step is make Gilman reagent, just like the last slide. And you need to follow 2 steps. First step, just add a lithium. You make alkyl lithium. In this case, is pentyl lithium. All right. And the second step, so first step lithium, second step copper iodide. Then you can make dipentyl copper lithium. That's the Gilman reagent. So with these 2 reactants, you combine together. Okay, pentyl bromide, dipentyl copper lithium give you 10 carbon alkane.